Hello and welcome. This is the first session of our series, where we introduce the basic concepts of DID in a simple and approachable way. To truly understand OmniOne OpenDID, we first need to know what DID actually is. But don't worry if you've never heard of it before. We'll take it slow and explain everything clearly, step by step. So, let's get started. Let's start with a quick overview. So, what exactly is DID? DID is a technology standardized by an organization called the W3C. It allows us to prove who we are, safely and securely, in the digital world. It increases security by storing identity information on the blockchain, and shifts the center of trust from institutions to individuals, a completely new approach. We'll go into more detail about this later. This lecture will explain the basic concepts of DID that are essential for understanding the OpenDID system. Since OpenDID is built on the DID foundation, we need to understand DID itself first. Let's dive into the main topic now. First, let me explain what DID is. In simple terms, a DID is a digital name that represents you. DID stands for Decentralized Identifier. It's a unique digital ID used online that is decentralized. Like a social security number, it identifies you. But it's stored in a decentralized way on the blockchain, making it nearly impossible to forge or alter. Some key features include: it's globally unique, only one per person. It's tamper-proof due to being stored on the blockchain. And it supports self-sovereign identity, meaning you create it, you manage it, and you prove it. So, how does a DID actually work in the digital world? Let's continue. Next, let's talk about the DID document. Put simply, this is like the certificate that proves your DID. It's a document that contains public key information and service endpoints related to your DID. DID operates based on public key cryptography. Let me briefly explain what that is. It involves a pair of keys, a private key and a public key. The private key is like your personal stamp or signature, and the public key is used to verify that your signature is real. So the private key must be kept secret and never exposed. But the public key can be shared with others for verification. Back to the DID document. Since it contains your public key and other metadata, it must be accessible to other parties. This document is stored on the blockchain, so anyone can access it and verify your digital signature. In practice, someone can look up your DID document, find your public key, and use it to verify that a digital signature was made by you. This makes it possible for DIDs to function as a reliable identity system. Now, let's talk about VCs. A VC is like a certificate about you. VC stands for Verifiable Credential, a digitally verifiable certificate that proves your qualifications or identity. It's similar to a digital ID card, license, or diploma issued through DID. VCs are issued by trusted institutions, and they are signed by the issuer. They are also linked to your DID, showing that the credential belongs to you. Thanks to digital signatures, VCs are difficult to forge, and verifiers can easily confirm their authenticity. So how are VCs used? For example, when writing a resume, you can attach a digital diploma VC to prove your graduation. Or, if you submit a driver's license VC, a rental car app can instantly verify your eligibility without extra steps. In short, VCs are the core unit of information in the DID system. Now let's move on to VPs. A VP is a way to present a group of VCs. VP stands for Verifiable Presentation. It's a format that allows you to submit only the information needed for verification. Choosing from among your VCs. Sometimes you'll need to submit multiple VCs at once, and sometimes just a selected few. The key benefit is that you can share only the information the verifier needs and nothing more. For example, when receiving a package, you might only share your name and address. No need to expose anything else. Or during a job application, you can submit only the VC that proves the relevant qualification. So, a VP is the format or method for submitting your VCs. Next up is the concept of the wallet. A wallet is, simply put, a digital wallet. It stores your DID and VCs securely and helps you use them. It's the secure container for all your identity data. From the user's perspective, you need a secure place to store your credentials and use them safely. That's what the wallet is for. It securely stores your private key, keeps your VCs, signs data digitally, and creates VPs all in one. Typically, wallets are mobile apps, like a real wallet you carry around, but they can also be implemented as SDKs or other tools. A wallet is essential for identity proof, VC selection, and secure storage of your credentials. It really is like a digital wallet holding your DID document, private key, VCs, and more. Next, let's talk about ZKP. ZKP is a technology that proves something is true without revealing the actual content. ZKP stands for Zero Knowledge Proof. It verifies the truth of a statement without exposing the details. That's why it's called zero knowledge. Even though selective disclosure with VPs already offers privacy and security, ZKP goes one step further. It lets you prove something is valid while keeping all the data private. That's why it's considered a privacy-enhancing technology. When used with DID or VCs, ZKP provides even stronger security. For example, you could prove that you're an adult without revealing your exact age. In other words, it proves you meet the condition without disclosing the underlying data. ZKP is a powerful technique. It proves facts without revealing any private data. And when used with DID, it becomes a powerful tool. You don't need to understand all the math behind it. Just knowing how it works conceptually is enough for now. Now, let's review how DID, VC, and VP are related. These three are the core components of a digital identity system. They work together to create, issue, and present identity information. To break it down, a DID identifies who you are. A VC is a certificate about you. And a VP is a selected bundle of VCs submitted for verification. Let's take an example. You first receive a DID, your unique digital identifier. Then, you get a diploma VC from your university. Later, when applying for a job, you can choose just the diploma VC from your wallet, create a VP, and submit it to the employer. DID, VC, and VP work together in an integrated way, forming the core of any identity verification system. Now let's talk about the blockchain. It forms the foundation of trust in this system. Blockchain is a distributed ledger used to securely store and share DID, VC, and DID document data without tampering. Unlike traditional databases, blockchain data is decentralized and created through consensus, which ensures data integrity. Since the data can't be altered, it can be publicly verified. DID registrations, VC issuance history, and verification logs are all transparently stored. This allows anyone to check DID documents, verify digital signatures, and track credential issuance by institutions. Thanks to blockchain, the entire DID system becomes much more secure and trustworthy. Next, let's talk about the issuer. The issuer is the party that issues VCs. This can be a government, a university, a company, any trusted organization. The issuer signs the VC using their own DID. So the VC can be verified based on that digital signature. The more trustworthy the issuer, the more reliable the VC will be. Issuers create digital credentials like ID cards, diplomas, or licenses. And they are responsible for the accuracy of the information. Each VC is linked to the holder's DID, so the proof can be verified using cryptographic signatures. Now, let's move on to the verifier. The verifier is the party that checks whether a VC is valid. Verifiers review VPs submitted by users and determine whether the VCs inside are authentic. They verify the issuer's signature and decide whether to trust the credential or not. Since VPs allow selective disclosure, verifiers can focus only on the information they actually need. Verifiers play a key role in access control, whether it's unlocking a service, granting access, or confirming eligibility. Now let's talk about the holder. The holder is the one who possesses the VC. In most cases, that's you, the end user. You store your VCs in your wallet, and you choose when and how to share them. As the owner of your credentials, you control your identity. This is self-sovereign identity in action. The holder receives VCs from issuers, stores them in the wallet, and submits them to verifiers as needed, such as for identity checks or verification processes. Let's now bring together the roles of issuer, holder, and verifier. The holder starts by creating a DID, their digital identifier. This DID is registered on the blockchain as a DID document. Next, an issuer checks the holder's identity and issues a VC. The VC is then linked to the holder's DID. The holder now owns this VC, and when needed, submits it to a verifier either as a VP or through ZKP. The verifier checks the issuer's and holder's DIDs on the blockchain, verifies the signature, and makes a decision. This interconnected process between issuer, holder, and verifier is what makes the DID system function as a trust framework. And that brings us to the end of our first lecture. I hope this helped you get a clearer understanding of DID basics. In the next video, we'll dive into the components of the OpenDID platform. See you next time.